what we're gonna talk about today on this regression and median lines of fit. It's a Desmos heavy relationship because it does all the work for you. Now I'm going to show you a couple other things for some of you that hopefully might help you succeed a little bit more. But for me, my goal is to always make sure you guys can try to do things by hand first, and then I'll show you tricks of the trade later on. But I got to make sure that at least I know that I've taught you by hand. Okay, so we've used on 4.4, they gave us lines of fit and a scatter plot to evaluate trends and to make predictions. If you remember yesterday, it was all about when we did it on yesterday. So Logan, the stuff's on YouTube, okay, for that one. Yeah. It is a prediction, an approximation, a guess. Now we're going to create equations that are exact, okay, that actually are referred to as a best fit line. Not just a line of fit, but the best fit line, okay? Then we're going to talk about linear regression, correlation, coefficient, what a residual means, and a median. So you've learned how to find and write equations for lines of fit by hand. Many calculators use complex algorithms that find a more precise line of fit called best fit line. We are going to use Desmos for that, okay? One algorithm is called a linear regression. We are going to type this algorithm in. We are going to use linear regression via Desmos, okay? Which will make it easier for you guys to go through this. Your calculator may also compute a number called, which it does, a correlation coefficient. Correlation coefficient. All right, so, and I'll show you all these numbers. This number will tell you if your correlation is positive or negative and how closely it is to modeling the data. The closer the correlate, there are way too many C's. The closer the correlation coefficient is to -1 or 1, the more closely the equation models the data. So this is what this means. Yesterday, okay, when we were going through this, we had a bunch of dots. And then we took a line, ladies and gentlemen, we did what? Right through the middle of that sucker. Okay, yes.
Why aren't we doing, did we already do 4.5?
We're skipping 4.5. You can throw it, you can pull it out, throw it away. The closer it is. So what this means is, ladies and gentlemen, the data, this would be a correlation coefficient that is not very strong, where there's points all over the place, yet you could probably draw a line through the middle. But it's not a very strong correlation. A strong one would look similar to like this, where if I were to come through, start erasing everything that was far away like that, and I put a line through those, that's really strong. What that means is that I could draw a line through these dots, ladies and gentlemen, and it looks almost like a what? Like a line. Okay, that's kind of what we did yesterday. If you guys remember, they had dots. They were either going positive like this or negative. That's what we're going to do. Okay, so today, I want you to proceed to Desmos.com. It used to be red. They changed it to blue. But click the button that says Start Graphing.
Oh.
Go ahead and do that right now. Yes, clean it. Huh? Yeah. Yeah, you can use that, or I can give you a different one. Yeah, if you have to charge, you can sit in the back.
Go, baby.
Yes, ma'am.
On your chapter 4 test, if there are questions that look like what we're learning, are we allowed to discuss them?
Yes, please. We're going to talk about that tomorrow. Amen. This is school. This is my work on the rarely used. Yes. Yeah, sorry, should be open. Yes. All right, so when you guys get on a decimals, it will look like this. Okay, let me pull it up. Yeehaw. Okay, now step 2 says click on the upper left-hand corner, click the what? The plus sign, and hit add a what? This is add, you click this, and I want you to add a what? Table. That's what it basically tells you to do. Now, ladies and gentlemen, on your notes, what I want you to do is add the first lines of the box. Okay, so for example, on here on your notes, you would go here, put these numbers in, please. 2009, 10. Remember, this is actually, just to let you guys know, these would be your x coordinates and this is your y coordinate, right? So make sure you put that into a table on decimals, right? Any questions on that? All right, so let me get back to it. And I'll put my numbers in while you guys are doing that.
Wait, how'd you do that one graph?
What?
How'd you do that graph?
What graph thing?
Yeah.
The X and Y, you see your notes. What does it say in your notes, number 2? Take, what does number 2 say?
But,
That's why I gave you step-by-step instructions. That's going to be 10. Bam. Now, once you guys get those plots pointed, those points plotted, okay, what you're going to want to do, ladies and gentlemen, is find them. It was blue. All right, and then click the plus sign at the table. All right, so what you guys are going to want to understand, though, is we have a little issue here. And the issue, of course, is what? Where are the dots? Well, what is the x coordinate? 2000 and what? My graph goes up to what? 10. So what do you think I need to do? Zoom out. Okay, please, ladies and gentlemen, do not tell me that either one, I graphed the points, decimals is broken, they're not showing it to me. Or 2, you use a graphing calculator and you say, I can't find them. Zoom out. Okay, remember, you're looking at a tiny little window until there's my green dot. So now I'm going to have to zoom back in, but I want to put it in the middle so that you can see it starts to do what? Come back into focus as you go through. So let me see. My scale is now, vertically speaking, my scale is to 1. Now, please be fully aware. If you zoom in and your dots do not look like this, that is okay. Okay? Because let's be honest, some of you in here, when you zoom back out and in, you're going to shrink the graph or you'll extend it. I had students earlier today where these dots were laid out horizontally. And then I had another student where they were turned more vertically. Does that matter? No. Okay? What matters is just the dots, and that's it. Now, step 3 on your notes says to do what? Proceed to line what? 2 and type in a formula. Yes, Declan? No, it's fine. It's like I said, as long as your points are right, it's how you zoom in and out. It looks weird and it screws it up. That's fine. See, yeah, that's what I'm talking about. Yours are fine, but your ratio is off a little bit, but that doesn't matter. Okay.
Did you get your points like that?
Huh?
Did you get your points like that?
Oh, I just zoom in and out. Listen, guys, like I said, some of you are going to accidentally go too vertical, and then when you come back, it's going to shrink it and look really weird. That part doesn't matter. Don't worry about that part. Okay? Just make sure you see your points.
Bro, why did all my work just go away?
You probably deleted it. All right.
Just put Y1 and then MX1.
All right, so did you do it in the other one? All right, so here, watch this. Ready? Here we go. All right, make sure you guys know it's Y1. And then it's the little squiggly line that is under your escape key. Looks like this. Okay, it's like a little wave. Whee! Okay, I don't know what the heck that's actually called. And then it's under your escape key. You got to hit shift and hit the squiggly line under escape, buddy. Right there. When I say under the escape key, yeah, it's right under the escape key. Okay, then it's MX 1 plus B. So you guys see what happens when I put that B there, right? Plus B. Ladies and
I
gentlemen,
got a line.
what you're doing is you are creating, so this is what you guys need to understand. Okay? On this formula, what happens is when you type this in, you are basically telling Desmos, hey, do me a favor, Desmos. Go find the X1. That's what this is. See, that's how that says X1. Go find the Y1. That's the Y1. Put them together and create a Y equals MX plus B formula. Now, it's more complicated than that, much more complicated than that. Okay, but know that Desmos is doing all the algorithm work for you to create an equation. Yes, sir.
I don't have a charger.
Sorry, I don't either. It was taken. So do you have a phone?
Yeah.
Use your phone.
Wait, how do I log in these first charges right here? Because those aren't
Would
showing
you have it
up.
for this laptop?
No.
I'm not.
Yeah, no, it isn't. The only one that would be Ari's got hers. What in Lord's name is that?
Oh, I don't know. I just hit slot right here.
Yeah.
Log.
I don't care. That's fine. You're fine.
But I don't have all those other.
Yes, you do. You don't need the E. I don't know where you made the E column. All right. Here's what you guys need to know for today. All right. On your notes, this is what I want you to know. You're going to write 3 things down, actually 4. So just to make sure you guys understand, at the very bottom of this table, you guys have your solid line that looks like this, right? You're going to write a Y equals the equation there, so save enough room to make sure you can go Y equals. All right, makes sense? Okay, so I want to know the R. The R, ladies and gentlemen, is the correlation coefficient. It's the number that says how close is this line to these dots. The R is what value? 0.98. Is that a strong correlation?
Yeah.
Is that number close to 1?
Yeah.
Please say yes, okay?
Yes.
That'd be like 0.98%, or like 0.98. That'd be 98%, or 98. Okay, so what you guys need to know, because if you look, this line touches 1, 2, 3, 4 points. And it's so close to the other ones that it's almost perfect. So this would be a good model for Ari, which is the example that it's saying about this is her pay rate. So should she be worried around 2020, if she goes in, what should she expect her pay to be around 2020? About $23 or $22.87. If Ari was in 2020 this year and she wasn't getting paid that dollar amount, should she keep her job or should she start to worry about, I'm not getting paid as much as I used to? She should start worrying about how much money is she getting paid what she's worth? Because she used to get a nice little solid line here. All right, so R is 0.98, which means it's a strong correlation, which means she could use this in the future for scaling. All right, so this is 0.98. What is my M?
1.21.
All right, it's to the hundredths. So 1.21. And then what is my M? Or my B, sorry. Stupid eraser. All right, B is, you said negative 2,000. Thank you, sir. And then what's the cents on that one? 0.04. So, ladies and gentlemen, guess what this actually will do for you? If I were to ask you to write a linear equation based on this information, could you do that right now?
Yes.
The answer is yes. Because it's Y equals M X plus what? Now this is a negative number. Do you guys understand what we just did here? I gave you a whole bunch of plots. And I wanted you to find the residual effect, which is 0.98, which means this is a strong correlation. Remember the notes we wrote above. The stronger the number or the closer the number is to 1 or negative 1 means it's a strong correlation, which means it's good data, okay, where you could predict the future. And it's not all over the place, okay? Unless something changes, that's how you would do it, all right? So I want to show you one other thing, okay? Now, what I'd want you to do is on the next one, you do the same thing. Okay, now, a couple of different rules of thumb. I want you guys to graph all these out on your own. You got to understand one real aspect of this. This is the first time you guys maybe have ever used Desmos like this, where you're typing in a formula. This is a formula. And what you're asking it is you're asking it to find Y1. If I create a new table right here, my new table actually has what value? Can you see that? X2 and Y to the what? It says X2 and what? Y2. Will this formula work with this one? No, the reason is this. You're telling this formula to look for X1. If I change this X up here to a 2, watch my line. What happens to my line? Disappears. Ooh, everything went away. What the? It's weird. It's going away. Oh, I know why it's going away. It's because of this table down here. My line goes away. Because now, but what if I change this down here from a X1 to an X to the, guess what happens? My line comes back. You know why? It's because you're telling this formula right here. I want you to find where the Y1s are. This is Y1. I want you to find, now we're saying X2. Where is X2 at? I changed this number and it's right here. So I want you to understand that this formula only works if you have everything lined up, okay? If you have X1 and Y1 at the top up here. If you have any other number than that, guess what you have to do? You have to make a match, okay? So that way you see a line. Please don't graph this out and then you do this and you don't get a line. Yet, will you still get an answer down here? Yeah. Is that the right answer? No. It's just some random stuff that's thrown out there. You will get this question wrong if you don't see a what? A line. Make sure you see a line, okay? That goes through your points. So find your points always, all right? Does that make sense to you guys? Okay, this is the first time you're ever writing an equation or a formula. And this formula has to point to the values in a table. If we were teaching you Excel, all right, I would teach you how to use Excel where, if you guys aren't fully aware, across the top of Excel spreadsheet, every little box is a letter. A, B, C, D, E, F, and it goes all the way to double A, 2 A's, 2 B's, 3, and it goes Z's, 2 Z's, okay? And then it'll actually go, I think it does go to 3 A's. I'm not sure if it does or not. Okay, but it repeats the letter, and then horizontally speaking, it's row 1, 2, 3, 4, 5, all the way down. Each one of those cells is unique. It's just kind of like anybody play Battleship, where you say C1, and you go over to C down 1 or down 3. If you go C3, you go over. Excel does the same thing, but you create formulas. This is a formula where you're telling Desmos, hey, transcribe this. Now, here's what I want to make sure you guys know. All right, now, that's number one. I have been teaching you guys, and some of you in here are gonna hopefully understand this. Some of you, some of my smarter students will get this. All right, so let's delete all the numbers in here. How do you usually graph a line? What have I been giving you recently? I've been giving you no slope, but I've been giving you two what? 2 points, okay, the X and Y value. Somebody, so Tate, I'm gonna put you on the spot. Give me a coordinate point between, that would be on this box somewhere, between 10, anything between 0 to 10. Give me a coordinate point.
1, 2.
That's fine. 1 and 2. All right, there's my 1 and 2. All right, it's already created a line. Well, it's because do you have y equals m? Do you have the formula down there still?
No.
Well, then duh. Give me another point, somebody. Yes, Ian.
5 and 7.
5 and 7? You guys are so original.
We only gave us the numbers for 1 and 10.
That's fine. Now, can you tell me what this linear equation is by looking at this on decimals? The answer is what? Why not? What do you need for a linear equation? Y equals what? So this equation for this line is y equals m, Tate, what is this m? 1.25. Now, here's the only problem. Usually, slopes are not in what? A decimal form. Usually, I'd want it in a what? Fraction. Does anybody know what 1 and 1.25 is in a fraction? If you don't, that would be a problem. If you do know what it is, then guess what? It's not a problem. And then, does anybody know what 0.75 is in a fraction form? 3/4. So could I write this formula out? Do I have to do all the extra math that I've shown you how to do? If you're smart enough, the answer is no. For the rest of you, do the math. And by the way, let me show you one other trick. I think it'll do it. It may not. On decimals, are you guys aware of this little button? If you put any number in most of the time, I put a number in 1.25 because remember, we have to have it as a fraction. If I put in 1.25, and I know this might be too much information for some of your brains, do you see what this button is? Do you know what that is?
Fraction button. It's a fraction code.
Dang. Okay.
So I never tell you. So I just did what?
You just gave us the cheat to all of our homework. You just
Y equals m 5/4 x plus what? B. I don't know what B is because I'm not that smart.
A plus 2 right here.
Yes, it is 3/4. All right, how about this fraction? Who knows what this is?
Well, let me just
I think I know what this one
press
is.
that fancy button. Let me tell you. It's
0.87. 0.875, I
0.875.
think. Oh wait, it might be 2.5.
That's right.
Oh no. 7/8.
Okay, ready?
So ladies, here's the deal. I'm going to be honest with you. Okay. Now, here's what I want from you. Is this a way? Are you using your brain to try to troubleshoot and solve a problem?
No.
To get to here, are you doing that though?
Yeah.
Yes.
No. Use your brain.
Press the button.
No.
Bada boom, bada bam.
But not everybody. You guys are going to. Some of you are going to forget how to do this, and then you're going to strain your brain. Oh my gosh. Or you're going to have to go back on YouTube and watch this video to try to figure out how I did it.
Oh, you.
Yes. I'll post this class because I have one posted right now that I got to delete because I yelled at a student and told him I'm sending him to the office. Well, yeah, you have to wear a mask. The student kept picking at it, pulled it apart, popped the thing off the side. It's great. You guys understand what I just showed you. If you have 2 points. Now, here's the key. Most of you will forget how to do this. Do this. Do a table and then do this. So am I worried? Am I showing you a cheat? Yes and no, because technically speaking, sometimes I'll be honest with you, I don't know, unless you know it off the top of your head, you guys will sometimes hit this. Okay, here's the problem. Do you guys know what that actual 0.33 repeating is? See, that's where it won't work. See, will it work all the time, Tate? The answer is no, it will not, unless you know what 0.33 is repeating.
Do you know that thing?
No.
I don't.
It is 1/3. That does not look like 1/3. So it won't always work. If it's a repeating decimal, it won't always work. Okay, so be aware of that. Okay, so you're like, well, I can do all my homework. No, You can't, because if I put in 0.666, well, I don't want to do that.
Okay, relax.
All right, if I do this one, okay, and I type in this button right here, guess what it'll give me? It won't give me an actual, it'll go 33 over 50. That is not what 0.66 is. It's actually 2/3. Okay, so you will get it wrong if you put in 33 over 50. All right, because technically speaking, if I add another 6 here, this will change again. It'll actually make it bigger. It'll go 333 over it because it doesn't know how to do it. So it can't do everything if it's a repeating decimal. Okay, now if it ends, if it's finite, like 0.875, 0.5, well, you should know what 0.5 is. My God, it's past. Okay, huh?
0.885, whatever.
I don't have no idea if that, buddy, I don't even know if that would work. That's fine.
That would work.
177 over 200. Yeah, I don't know if you'll ever get an answer like that, but if you did, good luck. Okay, so does that make sense? All right, so what I want you guys to do is I want you to work on the rest of this table function here. Okay, try these out. All right, so go back in the tables and continue to try them out. I'll give you guys about 5 more minutes just to practice. All right, because I went a little long on the explanation of how to use Desmos, but the rest I'll put the answers up so you can practice later. Yes, sir. We did 4-4 yesterday. We didn't do that page. You can rip that page and throw it in the trash. Were you here yesterday? No, we did 4-4 yesterday. You're going to want to watch that one, by the way. It's a short lesson, but you're going to want to watch it.
That's so crazy. It's just putting all of them in.
Yeah, it's supposed to. Then. I'm glad you're figuring it out. Right. Yes, ma'am. This. That's it. And then it's a squiggly line. And then it's in that
Price transfer to. Price times JT.
Welcome to your world.
Welcome to I Get Offended, so I switched schools.
Well, somebody said one thing makes me, so we should run away.
Gentlemen, remember this one's going on YouTube. Don't complain all about your fellow classmates or former classmates. Listen, the reality is, guys, as you grow older, you will experience lots of difficulties in life, and you'll see those individuals that once they get a hardship, they tuck their tail and run.
Or
I missed it. It's hard to hit the tic-tac. It's small. Missed it again. Huh?
I'm just not that talented.
No. Are you kidding me, buddy? I was.
are you kidding?
I can go. My handicap is 15, and I haven't golfed in three years. When I go to Top Golf, I hit the. No, I bring my own clubs. I hit the ball to the backstop every time.
Well, that's over.
Straight down the middle.
Hey, I can film that video of you as a boyfriend.
All right. So, ladies and gentlemen, make sure as you guys go through these today, okay? Let me give you the answers to these, and then we're going to move on. I'll give you the first couple ones. Now, on this, make sure as you're graphing it out, test it. It's going to be R equals 0.5927. M on this one is 2.52. And then my B value is a negative 540.37. Okay. Now, once you guys put these in, and then you can figure out that y equals mx plus b. All right. I'm not worried about that. Sorry, it's 5037. Okay. So keep working on. So as you guys, if you go home and you want to test it out, you can. All right. Now here, let me make sure I give you. I'm going to give you 2 on the back side here. All right. So the other 2 here, it doesn't matter. Here's the big thing is that for the first time on these ones, okay, and this is the only thing we're doing with Desmos is the this side of it. The other side you wouldn't. So go home later and try to see if you can duplicate this and come up with negative 0.55 for your R. See if you can come up with your slope as negative 0.94. Then see if you can come up with your B value of 81.53. Okay, if you can come up with those things, great. All right, and I'll give you the last one too. See if your R value is 0.959. Your M is 5.68. And then see if you can get your B value at 3.66. Okay, so try it out, write those numbers down, and then go home on Desmos and try it. Okay, listen, the homework, that's all you can do, is try using these techniques to answer the questions on the homework, okay? And that's it. It's simple, yet, ladies and gentlemen, I want to make sure you guys can do these things, okay? Any questions on that? All right, so let's get to the backside real quick because I got to fly through it since we have a short amount of time, and I showed you a lot of tricks on Desmos, and I want to make sure I get you the rest of this done, okay? Keep going, buddy, it's fine. All right, any questions? All right, so let's go to the other side real quick as we go through. All right, so what I want to make sure you guys understand, okay, on the back side, the very last thing is, on Alex, it's going to show you 4 pictures that look like this. Okay, and on those 4 pictures, you basically are telling me and comparing the objects to each other. Okay, like figure number 1, 2, 3, 4. You can kind of see the shapes, right, that go along with it. So here's what's going to ask you. It's going to ask you a couple different questions. Number 1, which data set coefficient is closest to -1? Which figure? 1, 2, 3, or 4? Well, if you don't know, let's look at this real quick. If you connect the dots here, this is almost what?
Perfect.
Perfect. So actually, which one would that be? If you look over here, what's that last question say? Which one would appear to be equal to 1? That would be figure what? 2. All right. Figure 3 is nice. Okay. This one here is a nice positive, right? But it's not perfect. 1, what is that? Which data set shows the least evidence of a linear relationship? 1. And then this last one here, if I were to look at this and draw a line, it would look like it would go what, like something like that? So is that a -1?
Yeah.
It would be. Okay, now, if there was one like this, going negative, would this be closer than this one? If it was negative, flip down? Yes. Okay, this one would look a lot cleaner. So unfortunately, depending on what we're doing here, that's actually the only one that is a -1. Make sense? All right, so look at the bottom 3, the ones underneath of that, and tell me what those are. All right, the answer to these questions are simple, right? Which one is closest to -1? See that? It would be 4, right? Because if you look, these are both -1 here and here, but this one looks a lot what? Cleaner, right? So it's more compact. There's less gap and white space. Which one is closest to 0? Which one shows the strongest positive linear relationship? 1. Okay? Simple enough, but that's what's going to be asked. And I'm going to probably put these on. I think I put this one on the test because it's dirt easy. All right, so let's talk about one of the more complicated things for you guys to understand. Now, and I'll show you an example tomorrow. Please make sure I opened up all the homework back up. Please make sure you guys do it. I noticed a lot of individuals haven't done it. And remember, it is a big chunk of your grade. And I want some of your guys' grades to go back up. So please make sure I opened up 4, 1, 2, 3, 4, and 5, and 6. 4 and 6. So there's 5 homeworks. I know you're like, oh my God, that's a lot. But I've had 4-1 open since the 26th for over a week and a half now. So if you never went and did it, go do it now to get that credit up because we're getting near the end here. Okay, where every little bit's going to start to help even more. All right, best line of fit is this equation. Now in Alex, it's going to actually give you a big graph. Under the graph is going to be the line of fit, and to the right of the graph is going to be this table. And then underneath all of it is going to have some explanations, and it's going to ask you these things. Okay, so for example, and I'll show you what that looks like in the homework, but I'm only doing one. On the homework, it actually has you do 2 examples for one graph. We're only doing 1 example for each graph, okay, for each function here. Okay, so let's look. It's going to say texting for 4 hours. So we take that and we go here, time spent texting. What is the observed time exercise? For 4, it is what? So for 4 hours, they found how much did they actually exercise? 4.5. All right, for the other table over there, working, number of hours of work versus money spent on fun stuff. Okay? Working for 7.9 hours, they observed somebody spent how much money? $33.50. So this number here goes up here, right? Because you guys see why? Because of what? This number here and this number are what? The exact same. This number here and this number are the exact same. Okay, that's what you're shooting for. All right, so we know this is going to be, all right, and then what it's going to ask you is it's going to ask you and Alex to tell me the predicted time. Remember yesterday when we did the lesson, the predicted time went off of the best line of fit. So you would tell me y equals negative 0.4, I'll get that in a second, plus 6.97. And what number do you think goes right there in that space? No, it would be the x value, which is the number 4. Steiger. Who? Oh, okay, yes, ma'am. Yep, thank you. All right, bye-bye. Who the hell is Corinne? All right. You're bye. Bye. You're leaving, bud.
Oh.
No, the secretary up front. Can I have Karim? I'm like, who the hell is Karim? All right. Is that how you say it?
Curry.
Yeah, that's what I thought. Okay. When she said Karim, I'm like, what the hell? All right. So on here, this actually what you're putting in is the same amount of time, which is the actual number 1. You actually need to put 4 in here. Okay? Now, ladies and gentlemen, you should do your simple math. So this would be y equals negative 1.6, and it's plus 697. And so it comes out to be a total of 537. Okay, so this is what your equation said you should do. Now, what it's asking you for on Alex is what's called the residual, which means what is the difference of the observed time minus the predicted time. Now, I know you may not understand what this actually means, but what it's doing is it's saying, okay, here's what we actually observed. Here is what we predicted. How bad did we mess up? Does that make sense? How much did we miss it by? That's what residual means, is how much did we miss the actual our estimate by? So on here, you would take your observed time, which would be 4.5, minus, because that's what it says, your predicted, which is what? 5.37. You put that in a calculator, ladies and gentlemen, and you would end up with negative 0.87. It's going to ask you all of this stuff in Alex. So what this basically means is, remember, when we here, let me make sure you guys understand what this actually means. All right, we were to actually, if we were to go through this and plot this out, what this means is that we would create a line of fit. All right, where on Desmos, if I were to graph this equation right here, I could graph this equation and create a line, correct? And then on this line, okay, it would actually cross at 4.5. My line, my point right here would be 4.5, comma, 5.37. But in reality, my point should have been what? Should be like right, actually it would have been 4.5, it would have been 4, sorry. What this is saying is this would be 4. In reality, I would have graphed a point right about here. And that red point would be 4, 4.5. So what it's telling me, asking me is, what is the gap between here and there? So it's saying, how much did we get it off by? We got it off by negative 0.87. And I'll show you later about that too, what that means, okay? I know it might be kind of complicated, but understand, if I were to graph this line on Alex or on Desmos, you would see the difference between the two numbers. So like this would be plotted, and I'll show you that before we leave. All right, so here's another one, predicted. So it'd be y equals 0.6x. Instead of x, though, you put in the number, which would be what? 7.9, that's right. Y equals 0.6 times 7.9, and then it's plus 22.3. And so what this is, ladies and gentlemen, is it comes out to be y equals $27.04. Okay, so how you figure out the residual is what? The difference of observed minus your predicted. So the difference is what? You put that in the calculator, you enter $6.46. All right, and then let me show you what it actually looks like in reality, what you just did. All right. All right, let me show you real quick on Desmos, and then you guys figure out the last two, and then we'll write that down. So here's what this actually means. All right, so I know we've been having fun playing around with this, but let me show you a couple things. This is what this means. All right, if I were to delete all these and I put in my formula. So on that last formula, it said y equals. So if I go y equals 0.6x, and then it's plus plus 22 point what? 3. Okay, so if I zoom out on this, okay, here's my graph. This is my prediction line. But in reality, this was my actual point. If you guys look on there, it says my observed time was 7.9. So it'd be 7.9. I put a comma here. I think this will work. And then it's going to be, I may have to put a bracket in front. We came out with 27.04. Oops. Yeah, it didn't work. Hold on. Okay, what this actually means, oh wait, our predicted, sorry, I put the wrong one in. It was, in reality, it was supposed to be what? 33.5. This is what it means. This is our best line of fit. This is the equation we created. But in reality, where's the dot? This is what we really observed. The R, what you found out, what that $6.46 is the difference between this dot right here and this dot. Okay, does that make sense? That's what's called a residual. All right, in Algebra 2, in calculus, in statisticians, they actually figure out the difference of here to see how good or bad something is. All right, any questions on that? All right, so that's actually what we did. We wanted to know the difference between this line and that dot, and we found out. The very last thing, so make sure you guys know on these last two, okay, as you go through these, you can do the observed because it's really simple. All right, it's 14.50. This one is 13.5, so you know it'd be 62.5. Okay, and then your predicted, just plug in the numbers, and then that will be it. All right, any questions? Hope you guys learned a lot today and you remember it. Now, I will post this one later, since this will be the one that talks about all the Desmos hacks in relation to this. It's not, you can use it some of the time, but remember, you can't use it all of the time. So you still have to know the math, especially on a repeating decimal, okay? Unless you know what 0.33 is or you know some of the other repeating decimals, it won't always work the way you guys want it, all right? Any questions on that? So I'm going to do the work on this so I can post it. Other than that, guys, that's it for today. So please make sure tomorrow when we come in, we will work on the little review book. We'll put all this information in the review book, like how to go on to Desmos and create the equations. I want you guys to write it in there so that way you can use the book. And when you say to me, hey, I got one of those line of fit questions on the test, how do I do it? Be like, remember, go to the book and you find it, okay? And then this is going to be y equals 1259. And then this is going to be 6607. So this would be observed minus what we think it's supposed to be. And it would be 1.91. And this would be what we thought it was supposed to be, what it actually is, what we thought it was supposed to be. And it comes out to be a negative 3.5. And that's it.
Yeah, nice. That's over.
Any questions, ladies and gentlemen? All right. Good job today, everybody. It was fun. If you have any questions, let me know later. Okay, watch the video if you need a refresher on the hack and Desmos, especially the fraction part. And good luck. We'll study up, start the review tomorrow, finish it Monday morning, or Monday at the first half of class, and then I'll let you guys start the test on Monday, finish it on Tuesday. All right, and that's it. Be safe.
The test correction is tomorrow, right?
Test corrections are due by tomorrow, please. If you have them, please bring them up here. I have a couple people that have dropped them like it's hot. Please make sure you continue to drop it like it's hot.